Hey, this is Mr. Warden. This is a key for Geometry Do Now 23.1, week 23, day 1. So you'll need to review a little bit of this. This is an important one for this. A line perpendicular to a plane is perpendicular to every line in the plane that passes through its foot. So for AB, the foot is B because that's where AB goes through the plane. And if AB is perpendicular to this plane, then AB will be perpendicular to EB, CB, and DB. It'll be perpendicular to all of those. Also, if a line is perpendicular to two distinct lines on a plane and that pass through its foot, then it's also perpendicular to the plane. So in 2A, we're going to consider this situation. We got ABCD is an isosceles trapezoid, and that means that it has two congruent legs. And it's in plane T, so it lays on plane T. BC and AD are parallel. These are parallel. That tells us AB and DC are the legs of that trapezoid, because then BC and AD are the bases of the trapezoid. We know that PF is perpendicular to plane T, which means it'll be perpendicular to any line that is on the plane that goes through the foot of PF, which is F. And we know that PF bisects AD. So what would be a segment that is definitely congruent to AF, and why? Well, we've been told PF bisects AD, so AF would have to be congruent to DF. So AF is congruent to DF by definition of a midpoint. Okay? Or should I say of bisection? Be more precise, because PF is bisecting AD, and that means it splits AD into two congruent parts with F at the midpoint. Okay, cool. If you drew FB, so we're going to actually draw lines. If we were actually to draw some auxiliary lines like this and this, how many degrees would PFB and PFC each be? So this is PFB and PFC. Well, BF and CF are lines that go through the foot of PF, and we've been told that PF is perpendicular to plane T, so that would tell us that this angle is right and this angle is right, as already were these two angles. Those are right angles too. So any line that goes through F that is on the plane is going to be perpendicular to PF, so we got all those right angles. Okay, so let's capture that. They would each be 90 degrees. Okay, and how that relates to the perpendicularity of a line to a plane is they go through the foot of PF, which is itself perpendicular to plane T. Okay, so now we have those angles are all right, which is kind of cool. All right, what segment is definitely congruent to AB? Well, if these two are parallel, and this is a trapezoid, an isosceles trapezoid, then AB and CD are the legs of that trapezoid. So AB is going to be congruent to CD, because that's a definition of legs of an isosceles trapezoid. Okay, so AB is congruent to CD. By definition of an AB. So AB is congruent to CD by definition of an isosceles trapezoid. Okay, so what angle is definitely congruent to CDF? So CDF. Well, what angle would be congruent to that? Well, that's an angle. That's a base angle of an isosceles trapezoid, which means BAF would be congruent. So angle CDF is going to be congruent to angle BAF. Okay, and that's by base angle of an isosceles trapezoid. Okay. Now, let's take a look at the proof for this. So we have some information that we've established. We established that these two segments are congruent because they're bisected. We've established that this angle and this angle are congruent. If I draw FC and FB, I'll have right angles. And we're trying to prove triangle PAB and triangle PDC are congruent. Well, to do that, it would help to have this side, and this side congruent. It's going to be hard to get the angles for these. So side is probably going to be our better bet. So we're going to have to start by figuring out these sides. To do that, you're going to need to deal with the triangle PFA and PFD. So let's start with the given. So after the givens, we can start saying, we can say that AF is congruent to DF by bisection, okay? Because they've been AD has been bisected. We can also say that PFA, this is angle PFA, is congruent to angle PFD, okay? And that is by definition of perpendicular, okay? That PF is perpendicular to plane T. All right, now we have enough. We actually, one more thing. We can say PF is congruent to PF by reflexive. Okay, and now we can say that triangle, because we have an angle, and we have a side, and we have a side congruent to itself. So I'm actually going to label some of that. So we have this side. We have this side and this side. And we have this angle here and that one as well. So these are all, so I've got side, angle, side, angle, side for this. So I can now say triangle PFA is, let me see if I can do this without deleting, is congruent to triangle PFD. Okay, and we can say that by side, angle, side. All right, now that we've got that, we can say that PA and PD are congruent. PA is congruent to PD by corresponding parts of congruent triangles are congruent. Nice. Now we're starting to get somewhere. So I'm going to mark this and this. All right. At this point, we're going to need to draw some lines because in order to get the next triangle, we're going to need to get these sides. All right, but let's go ahead and name that because it's isosceles, we can say AB is congruent to CD by definition of an isosceles trapezoid. Okay, so let's label that. So I'll mark that there and this here. Now, we're going to draw some lines. We're going to draw FC and FB. Scroll down a little bit. Draw FC and FB. FC, actually. what we're going to do is I'm going to name some angles. So let's draw those lines. So I've got to draw this one and draw this one. Now you might notice I've set up the triangle PFC and PFB now, which will, if we can prove those are congruent, then we can prove PB and PC are congruent. And then we'll have enough to prove that PCD and PBA are congruent, which is what we're trying to do. Okay, so let's do that. So what we can say, and I haven't proven yet that these sides are congruent, but we will in a second. So what we can say is that angle PFB is congruent to angle PFC because they are perpendicular to, because FB and FC are perpendicular to PF and therefore congruent because they are right angles. Right angles are congruent to each other. Okay, so we can identify that this angle and this angle are right angles. Okay, but we're going to come back to that. Now we know that these angles, so actually let's deal with that. So angle BAF, did I already deal with that? No, I have not. Angle BAF is congruent to angle CDF, okay, base angles of an isosceles trapezoid. I dealt with that in a previous question. That's why I'm remembering it. So if that's true, okay, we can go flump and flump here. Now we know AF and DF are congruent. We know AB and DC are congruent. So we got side, angle, side. So we can now prove that triangle, okay, I'm going to say ABF is congruent to triangle BCF. And that's going to be by side, angle, side. And once we have that, now we can say that FB is congruent to FC by corresponding parts of congruent triangles are congruent. All right, so let's go ahead and label that. Flump, flump. Make those little blue lines. And now we already know PF is itself. So we can now say PFC and PFB are congruent because their angle, this angle here and this angle here are congruent. So we got side, angle, side again. Side, angle, side is getting a lot of work today. So we can say triangle PFC is congruent to triangle PFB by side, angle, side. Now we're almost there. Now we can say that PB and PC are congruent by corresponding parts of congruent triangles are congruent. And once we have that, we can say that triangle PAB is congruent to triangle PDC by side, 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 because we have now proven PC and PB are congruent. We have this side, and this side. So we got side, side, side. We can finally prove it. Triangle PAB is congruent to triangle PDC by side, 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 and you are done.